So today I'm doing a more chill stream. Basically, I need to create this collage of videos. Basically, this meaning. Actually, let me update the title. Title of stream. Making collage video for a presentation. Yeah. Oh, let's see. Restream. Sorry for that. I just sipped. Pretty ugly. Date titles. Yeah. Actually, I need to stop the music, I think, because it's just the quality is so fucking bad.
Okay, so where is the music? Let's see. It's here, I think. No, it's here. Yeah, there we go. Zelda. Oh, am I about to get fucked? Well, I found this last night. So I found this. Let's see. Why is it so hard to connect my shit? Anyway, so I'll make a small intro very soon. Only I could connect my things. Oh no.
I need to connect here, won't it?
So I have this trope I found. It's called Pilot Red Sun. I heard it's great. So I put it on my headphones from my phone because basically I have an issue with the audio when I'm streaming, so the quality is very bad. So what I'm doing today is the following. I have these videos that I have exported a while ago, and they look like this. So it's like our method versus state of the art versus the other our method. So these two are our methods, and this is like the state of the art. I mean, this is the state of the art. And as you can see, like our method, I mean, even this one, but especially their method, actually in this video is like most of them except this one, they like fluctuate, right? So they have all this, like here it's land, no wait it's forest, no wait it's yeah, so it's just yeah, it's a hill now, and here this is more stable, right? Like I won't say it's perfect though, yeah, it kind of has some point. This one also fluctuates, so I'm not gonna lie about it, but this one doesn't. And I have like 5 of these videos, right? And they're all on various places. So let's look at this one. As you can see, this fluctuates a bit, This one is quite stable. That's great. I don't know why it's stable, to be honest. Like that's a pretty big question mark, but it's stable. And the nice part about it being stable is, well, you can argue it's a better performance because, like as you can see, it doesn't like it stays consistent across time. And we have a metric for this, called the consistency metric, where you just look at the previous frame and the next frame, and yeah, we warp using optical flow. That's a bit of a technical thing. So basically, what warping means in this context is the following. We actually have a what is it called? Not conf. I forgot the name of the tool I want to use. It's mirror board. Yeah, there you go. They have a mirror board. And sometimes I just type stuff in this mirror board, usually when I'm streaming. So what did I even do here? Static. Oh, I remember. Yeah, I remember I did this. It was quite cool. Eventually I did HTTPS as well, but that's a different stream. So I think this is on YouTube. This is my Golang tool. Anyway, delete. So, or should I delete it? Yeah, let's delete it because I can always like recreate this stuff. Boom. So I have the following. Let's get another one of these boxes. Is it white? No, it's not white. Okay. So you have this frame. Yeah, let's call it frame t. Frame equals t. Frame equals t. I wish everything was white here. Oh god. This frame equals t, right? And in each frame you have like, how do I draw stuff? There's a pen. Let's use a pen. There you go. Wait, with a pen. This. Can I make it white? I can. Okay, so you have a frame. Let's assume it's a 4x4 grid, right? It's a 4x4. Why is it so hard to draw? Okay, right. And then you have the same thing like twice. You have frame t minus 1. Oh my god, you can move this. Okay. Okay, so you have frame equals t, frame equals and frame equals t plus 1. And basically you have optical flow, but before you get optical flow, let's assume you have two classes, right? Let's assume you have cats and dogs, right? So you have maybe 0 and 1, cats and dogs. Let's put 0 and 1. Cats and dogs. Okay, let's put cat, dog. Assuming that these are pixels, these are predictions, right? Have dog. Let's do only this 4 because it's easier to explain. Maybe it was easier, yeah. And then on the next frame you may have actually maybe even dog just to prove a point here. So you have dog, cat, cat. And on the last one you have, let's say, let's put cat here, it doesn't matter. And let's put dog here. I have like, I don't know, cat, dog, cat, something like that. And now let's look at the very particular pixel. Let's look at, which one should I? Let's look at this guy. Let's look at this pixel. So let's make it red, maybe just for this. So we're gonna look at this pixel, and the question is, how does it change it in time? So obviously the easiest thing you can do is you can look at this pixel and at this pixel, and that would assume that that would assume that the frame doesn't move, and that's not necessarily true, right? But let's just assume that it doesn't. So that means our consistency metric is basically consistency equals consistency from time t minus 1 to t plus consistency from t to t plus 1, right? So that means we basically split it between consecutive frames. Let's use t as a reference here so we don't complicate our lives. What I did here is t minus 1, and you can divide this by 2, right? And now the question is, what is consistency t minus 1t? So what is it? Equals, it's for each frame. Basically you look at it's basically 0 if how do I put it, like pixel ij t minus 1, and it's 1 if they are equal. Alright, and this is how you compute it. Basically you look at whether this pixel changed here. Actually it's the other way around, because I said that we're so equal, and the same you look for it here, and you're like, is this equal? I like this dot, right? And you're kind of asking this question, like, how I do this better than how I do this. I don't know, equal. And if it's equal, you get a 1, otherwise you get a 0. So it's like 0, 1, 0, 1, and then you do that for all the frames, right? So all 16 of these, and then you do that for minus 1 and plus 1, and basically you get a score that's between 0 and 1, and you can have like basically, yeah, and you get a score between 0 and 1. Okay, you also divide by 2 here just to be correct. Let's yeah, it's kind of like that, and you have yeah, it's a dot that I added over there. Holy shit, I added. Okay. Great, so this is how we compute consistency. Now there is another issue here, is that if your change is if your scene is changing very fast, this doesn't really hold. So let's assume, so this is like without optical flow, consistency without optical flow, and this would actually get you to a good place, because that means you're kind of assuming that between two frames things don't change that much. So maybe it's worth not taking into account the fact that the scene moves, and you can get to a very good place. But if you want to be more precise, you introduce this concept of optical flow. So what is optical flow, right? So you go from frame A to frame B. Let's say frame A, frame B. Let's delete all this drawing stuff. Oh, I like this song so much. It's a good song. I'm sorry you cannot hear. It's called something with Red Sun, Pilot Red Sun, and the song is called Warsaw, I think. Yeah, Warsaw. Very good. And can I delete? Okay. How do I? Oh my God. Okay. Hello. What? So this is t minus 1 and t, right? So let's assume it's, or t plus 1, it doesn't really matter. Okay, so the question is, where did this frame, let's assume I'm looking at this particular frame, where did it move? From t to t plus 1. So assuming that you have like a dog or something, right? So at the beginning of let's say a movie, it starts somewhere on the right, and then as the movie progresses, it just goes towards the scene. But if you look at a specific point, let's assume that maybe I can get like two like dog. Let's take a dog gif outside. Yeah, there you go. Maybe not a dog that's running. This dog is running. But like that. Dog gif outside park. Is the dog running? Yeah, the dog is absolutely running. There you fucking go. So what? Okay. I just don't open it, Jesus. Okay, so let's take two like pictures of this dog, right? So you have picture A at the beginning. Here. Oh, it doesn't. What? Oh, there you go. So you have frame T. Right? Have this dog. And then you have a later one, which is like at the end. Like here. Is this a good one? Maybe the first one. I think it's a good one. Okay, let's use this one. Maybe the first one can be a bit more exaggerated. Okay, I'm gonna try make the first one a bit more exaggerated. Not sure if that worked, but let's see. Oh, that's too exaggerated actually. Actually, maybe it's not a bad idea. Okay, I'm gonna give it one more shot. There you go. I think I got it. Yeah, there you go. I think this one is a better first frame than this other one. Kind of. Okay, so I have this and that. So the question is, semantically, where did this spot, let's assume his nose, where did it move, right? So how did it move? Assuming where did the frame where did the frame of his nose move? Now obviously you've got some distortion, so obviously the point here is smaller, so it's a cluster of frames, or better said, a cluster of pixels that's smaller here than here, but semantically they're the same, right? You can do this for anything. Like you can do this maybe for this tree. I mean, maybe this tree, like this one with this one, right? Like as you can see, you can do this with this, I think. So all of this, like, they are the same things. Of course, for grass there is a lot of ambiguity. There's stuff coming, so this is like new. This is like new stuff. And then you've got like this is stuff that's no longer lost. So obviously optical flow is not perfect, but for those frames where it is perfect, assuming that you can somehow reliably detect that, you can see how it's changed. Now, if you have this information, and of course between two consecutive frames is much easier, because this one was a bit exaggerated to prove a point, right? It's like frame T is this T, and like 3 seconds later, right, it's T plus, I don't know, 180 maybe, if it's 30 frames per second. But the question is, okay, we know this is nose, right? And assuming that we know the position of the nose here, you know the position of the nose here, and let's say we scale it properly, right? So this one is is an area of y, this one is an area of x. You kind of like shrink them together based on this multiplying factor that the object is closer. But assuming that you know, you must know that this is nose. So the question is is it nose in both frames as predicted by the semantic model? Or better said, are both pixels clusters pixels predicted as nose by the semantic model? And that's a question, right? And we are assuming that we know where they are. This is exactly what we did. So we are using this concept of optical flow. So this is optical flow. And what you get with an optical flow, you get like two images. One of how much this pixel moved from frame t to t plus 1 on the right, and then how much did it move on the x-axis and on the y-axis. So basically this one moved like a bit higher, right? Like it moved, let's make it blue maybe. So it moved a bit higher, so let's try to draw something that's quite like that. So it moved like higher. Maybe let's do it with white. Right, so this moved kind of like this, okay, on the y-axis. So it moved like that. And also, how do I do on the x-axis? Let's see, that one was easy. Maybe we can do it like this, and no, so it's probably around here. So on the x-axis it probably moved yeah, right, so it's something like that. It's just an approximation because it's harder to draw it. Maybe I could have put it like below, like, but let's assume that it moved something like that. And this here is a delta x and delta y basically. This is delta y. Oh my god, this is, let's put it with red again because I think it's better. Default colors cannot be removed. I don't want to remove it, I just wanted to, what? This is delta y. And this is delta x. And for each pixel, you get a matrix like this. Where did you move on the left? Where did you move on the y-axis, basically? Or on the left-right axis, and the top-bottom axis, x and y-axis. You get like two of these things. And this is like optical flow. It's like two matrices. So optical flow equals two matrices, the x of image shape, right? The x, how did each pixel move in x-axis, and the y, how did it move in y-axis. And basically this is optical flow. Right? Now we have this, so we know if this moved from here to here, we can look at it each image. Okay, so we look at this pixel, we look at this pixel, we know that their correspondence from here to here exists, and then we go to the semantic prediction and we look, okay, here it was cat or nose, let's say here it was nose. Is it also nose, let's say here, assuming that the optical flow moved it properly? And the same question is, okay, we know this is nose, and let's say that it moved here in the next frame, because like the dog is a bit, maybe the camera is shaking, the dog is running and all of that, but let's assume that we have a perfect optical flow. Question is it also nose here, is it nose here, and is it nose here? So basically the question is the semantic network consistent across frames, given the fact that we know the movement or the motion, or the motion field is also called in some sense, this optical flow. And that's kind of what we have. So we have for each frame basically a score of consistency taking into account the optical flow. And that's what we work with. So for these videos, I have this CSV file. So I have 5 videos, and I also have like 3 CSV files, which is called consistency for the 3 methods. This is sort of like our method, or the other our method, and the ground truth. The ground truth is M2F. And for each frame, we have a delta, because we just look 1 frame ahead, 1 frame behind, and we have the score. And score is in percentages, but it's basically between 0 and 1, and you have a score of 0 if you look at 2 frames, the previous one and the next one, I think. Yeah, I only computed for delta equals 1, I think, yeah. And for each frame you have 0 if they are the same, 0 if they are different, 1 if they are the same, and 0.5 if basically it's the same in one frame but not the same in the other one. Yeah. And as you can see, most of the time the network is consistent, but not always. Like for example, you look, especially when the things change very fast, like as you can see, like it's a 3%, that means 3% of the frame change. And you can see this visually, like if you look at this, let's see, Castello Corvintor, which I saw earlier. What is it here? Okay, I think this is cool. And if you look here, like look at master form, like it changes a lot. It like changes. That means like from frame to frame it changes about 3%. And you can see even in the labels, 3% of the image. It's not so obvious, but it changes. This one is more consistent. It's like 99%, like 1%. This one is also not so consistent, but it doesn't matter. Now I want to cherry pick, because we are making a presentation. So that means I have these 5 videos. I have these consistency scores. I want to find like the consecutive frames where they change a lot and we don't. Like for example, in this area, like this is at the very end of the video, as you can see, like it changes a lot because it like moves faster. The video moves faster, so it kind of makes sense. But our method is still consistent while theirs is not. And if you look at the CSV file, at the very end of the video, like here, you get scores of 97, 96, exactly as the video shows, right? So what I want to do is the following. I want to take our method, the best one, so this cons distill, which by the way at the very end of the video also has like 99, scores of 99, 98. I want to make the difference between them for each frame, and then I want to find consecutive frames of like 100, 10 second, 300 chunks, and then I want to get to sort like the most obvious places to cut the video. And then I'm gonna do this for all the videos, and I'm gonna make like a collage out of them with like the worst places. We're basically going to maximize the inconsistency, or let's say the consistency difference between our method and their method. Yeah, let's close some of this stuff. So I opened this, okay. Video paths, let's call it video paths. Root deer. Video. Oh my god, okay. Why is it moving like that? I don't know. I'm afraid if it's gonna lag, it's gonna suck. Okay, so yeah, let's do maybe some of this. Import. By the way, this is Jupyter Visual Studio, and it's nice. I'm also connected to a server, so it just works. It's a bit bloated, you could say, but kind of works. Now let's load the videos. I have this tool, VRE video, video path, video path, video paths. Alright, and let's print video path, video shape, video.fps maybe. Okay, for video path, video in zip, video path, videos, and SP prints, prints. Something is broken here. I think I'm missing the parentheses, and now let's see how fast it will load. So it loads quite fast. Okay. Now like this, from path, link for path. The fuck happened here? June. This is better, except the first one. Which I can fix by just adding. There you go. And maybe I can even do like a, do you do this? Interesting. Different frames per second for sure. That's not necessarily a problem. Okay, now let's load the consistencies. So consistency is equal path. I don't even know. So you have what? So basically I need to add out at the beginning of the thing. So that means it's I just do this. Hold up, what the fuck happened? See, this has happened before, to be honest. I don't know what's going on over there. Okay. Video names equals, maybe I need to do this stuff. While it's lagging a bit, but it's fine. I guess we can make the best we have. Okay, so we have this, and then we have root video plus video path or video path plus video name. Video names, and I have this, and it should be the same. I have CSV's path, which should be what? Root dir plus alt underscore plus video name for video name. cons is equals, I have two of them. CSV path plus cons m2f.csv cons distill.csv or CSV path and CSV paths. Alright, and I think I can do this print. How do I do this? Should do some shit like this. To be honest, maybe I do this cons diff distill cons distill equals that means I can do the same shit as I did here, just can do this cons shape distill shape, and then I can go on the next line cons distill video path cons distill and I meant cons distill cons all that. Cons distill cons cons distill doesn't have a cons distill. Which one do you not have? Forgot the slash. There you go. It's not the entire thing. So that's an interesting. I got 12K. Got this. Okay. Got this. These last two ones are not full. Interesting. Why that never end? Interesting. That's fine. Got enough frames. Norway one is like the worst, but they cherry pick something? Okay, cherry pick from 5 to 5. Oh, not. Okay, so I need to do some processing. I didn't expect that. So this is from 10 to 10. 10 to 10. Alright, great. What about this one? This is not 10 to 10. Oh, that's. Okay, so which one? Comana. Comana is still is 10. No, I meant Comana. It's something. It's 10 to 10 here, but the beginning it's 1 by 1. Okay. So I need to do some processing. I'll just duplicate, or maybe I can like lerp. I think I should lerp. Lerp or duplicate doesn't really matter. Cons mask to former, it's kind of in the similar state, isn't it? Yeah, it is. It just jumps here, so it's got a bunch of jumps. So then, oh, it's 10 by 10. So I think at some point I did 10 by 10, so it's faster, and I never like updated it. Okay, so I need to do some processing. So for example, for Norway, I don't know, if I LORP it shouldn't affect, especially since it's so consistent, like it's 5 by 5 here. Where did it change? Oh, what the fuck? 2980. Oh my god, it's sorted in such a weird way. What the fuck? Okay, it's weird sorted. I think I remember what happened. Yeah, I did it 10 by 10, then I did 10 by 10, but I alternated. I think I used like 2 threads or something. I don't know what I did. Anyway, so I need to LORP it for sure. So let's first sort it by frame. So I could use like columns equals frame, and that's their score. Punct set index frame punct sort index. I think this is how I should do this one. Cool. Columns. Doesn't like columns. Use quotes. What? Score not found on some distill one. Score, 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 score. What? Did I type it wrong? So const distill. So I opened all of them. Got score. What the fuck? Score, score. Well, let's remove this. Happy? Oh. So const distills. There's nans there. Columns for chain. Oh, const distills. It's got. Oh, it's. Funny. Const distills. So some nans. Where is the nan? Where is the fucking nans? Can I drop now? Drop nan. There we go. Didn't drop nan. Float 64. What? Which one is this? The last one, no? fucking confused. Where is the nan? Is the index not numbered? I'm actually fucking confused. If I do this, where is this nan? Jesus, what the fuck? Okay. Not, I'm gonna... This is so weird, what the fuck's going on? Ronald. It's still a nan over there. It's on this 3000 crap. We have this 3000 crap, which I don't know where it is coming from. Weird. Never mind. Let's don't give a fuck about that. This is so weird. I don't know what this is. Okay, so we have those. We have A and B. We have basically consistent. So we have for each video. So let's go for video. Consistent. Cons into F in 0 videos. Consistent. To be honest, I don't even care about that. Now I need to lerp the fucker. So basically, what I need to do is let's go to consistent 0. This one is fine. Let's go to this one. This one is a bit more tragic. So what is lerp? I need to lerp this thing. That means I will go from this to this, and I will just sort index. So how do I do this? Def lerp. Such an annoying function, to be honest. Gives me data. So you have diffs, which is data 1 is data 0 minus 1. Bro. I'm happy. What? Why is it so fucking bad? Data is data. Yeah, Okay, so that means it's 5, 5, 5, 5, 5. And yes, I need to do basically the following. I need to do a linspace. It's such a weird code. So I love it, but it's weird. So I do this and annoyingly so differently shaped. What? Why is this 5, 1? Flat? Thank you. There we go. Okay, so fuck. So what this means is basically I have this at x. I need to put a -1 here. This is, I have a x, bam, 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 x. And I need to add this. Then I have bam, 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 x. And it goes. And that means new array. And this is like div 6 0. Right, and this is div 6, so on and so on. New array has some div 6 entries. Okay, so that means let's do it like that. So I have a new array. Let's call it res. Res equals numpy zeros of length data plus divs dot sound. Rest dot shape 2981. I know this number. Why do I know this number? Is the number of frames in total. Cool. So now what I need to do is the following. So I need to I will need to do the following. Do x. Well, let's say that this is a. This is b. This is c. A, B, C are the existing entries. And now what I need to do is do A, B, 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 C. So I need to do that. So I do that with I think I need to do it with 4. Data minus 1. And we need to do this. Offset equals 0. Res from I plus offset I plus offset plus delta part of equals this x. And then you do a plus b minus s dot 5 4 b minus a dot plus 3 b minus a dot 4. This is not good. It needs to be over 5, I think. And then you have b. And it's the same, right? Okay, plus diffs x, the a offset equals new data offset plus equals offset, and new data equals what? Equals yeah, I think we can just diffs plus I times, let's just do that, is the I For j in range length is x y minus. There you fucking go. Is that correct? I don't know. Let's see. Let's do break. Let's print. Napa has no len. So let's see what the fuck did I do. So I have, and I think I forgot to add something here. Yeah, I think slurp data e, and you need to do data a plus slurp data e. Is this like a ChatGPT thing? Maybe I should use ChatGPT. Should I type code? Slurp data y. Let's see. So we have 99.blah to 99.99.83. So that means this definitely didn't work. Well, first one is and to debug. Yeah, this is, yeah. So this is oops. I have to make these groups right. And I have lux. I have all this great stuff. To be honest, I think this is also a plus, it's just 0 minus b minus 0.5, right? Dot. Yeah, so maybe I should just put LARP data over there just to make. So what's the diff? The diff is this bad boy. B minus L. Let's just use the same numbers. So I have A, B equals data dot E dot B plus. I have J, okay, and then you have over 5. Let's have like any. Basically. So NE is this bad boy. Here. NE equals this x minus 1. Jx equals range. Yeah, so wherever I have this, it's NE. Jace. Rotate. To be honest, I think it's like this. What? So this is fine, because it's supposed to be 5 of them, right? Yeah, maybe I should have just... Refs is A plus flops. Stops plus refs. Great. So the problem is, okay, Lord data. So that means this stuff, car offset. There is something retarded here, but I don't understand. So I have this, so the J's are happening fine, right? This stuff is happening just fine. Just for all. Have B, I have A. Int. This is growing and it should get smaller and smaller, but it, oh, no, it should shrink, but it doesn't. And that's wrong. I don't know why it doesn't. So it's diffs. Because I don't understand why I put diffs here, to be honest. This is fine. So if I add dupes, where's dupes? Did I forget dupes? Maybe I didn't ever do it, did I? I think I ever did it. No, so that means I should add A. And it linearly interpolates it, I think, right? Alright, so if I do this and I just do this, 0. Why 0? The fuck is this 0 here? Oh, I messed up something. Yeah. Ugh. This is a -1. I'm supposed to do -1 here. No, la final de tot se bușește. Yeah, the last one sucks. I put a +1 here. this it. Interesting. I think it's +1 here. Yeah, understand. It's +1 here, and then the last one has no offset, so that means you need to do it manually. That means you need to do res dot -1 equals data dot -1. So you have this and this 99.03. I lost it. Where is 99.03? It doesn't work. This is not correct. The first ones are definitely correct, but the last ones are not. I don't understand what's going on at the last ones. Holy shit. That's ChatGPT. What's wrong with my LARP data? I do this 99.9. I need a 12 here. 99.9. Okay. Oh, I missed. It's res and data. Oof, I put it on the other way. 9. Oh, it's good. It's good. It's perfectly correct. There you go. Yeah, never mind. ChatGPT figured it out. Let's see if it thinks it's an error. Yes. Amazing. Oh god. So let's do a test. So I have xs equals supposed to be, so let's put what 0, 5, 10. xs is equals 0, 5, 10. Set lerp xs x xs equals 0, 9, 10. Supposed to work. None. What? Bro. Like list. Happy? There you go. Cool, so this is fucking lerp. It diffs because I've used b minus a here. I mean, I needed this one anyway, so that's fine. Diff 6. Cool, so this is lerp. I'm so glad I did it on stream. There you go. And this has a proper shape. There you go. Okay, cool. So now what I need to do is basically I need to do this for a bunch of them. I don't even know, like, can I do it like this? Then children do it into this. Explain. Yeah, the first one is annoying. What do you mean? It's not the same. Tool is, oh, it's not the same. How many of them are there? Slurp working for... I think I had that nice slurp test. What about 0, 1, 10, 0, 5, 10? So it's supposed to do a bit more complicated with 0, 5, and then just a bunch of crap. But I don't know. Let's see. That. Works. That's nice. I forgot one of them. What the fuck? Okay, so yeah, it works. Great. So that means, yeah. Cons distill slurp equals blah. There you fucking go. Okay. And I need to do this. Let's assert this crap. Assert. Fuck off. I fucking hate this. Oh wait, cause yeah, this is just a. Okay, okay. Okay, I need to do something like this. This equals slurp. This equals. Ah. What the fuck? Oopsie. Classic. Amazing. Okay, so I have everything now. Jesus fuck. Cool, we have LURPs. Nice. So what's next? Finished with the crap. Cool. So let's go from each of them. So let's do this. Let's say cons into f equals cons into f slabs cons. This still equals cons. This still slab 0. Video equals 0. Oh, cool. Maybe I can even do that. Yeah, that's great. True though? I don't want to do that. Okay, so we have that. We have to fix. Can manually check. Yeah, it's almost all the same. Fuck. What? Okay, yeah, that's fine. Okay, so let's now go through this video and let's do this. So let's say cons diffs. Cons diffs equals cons is still minus cons m to f. So this is a difference in score. And now the question is, can I get like consecutive chunks? So what I need to do is the following. I need to do some sort of a convolution. 1D convolution, right? I need to get like the partial sum. How do I do this? Can I do a convol 1D and just get it done with convol 1D, convolve. Diffs. Range 30.30 to deep. Mode equals valid. Values. So good. There you go. Okay, what modes are there? Mode equals full. Mode equals same. Like mode equals valid the most, I think. It's valid chunks. The problem with mode equals valid is that yeah, mode equals valid is the only valid one, isn't it? So what I need to get out of this, so basically now what I have is the following. I have a bunch of chunks. They're convolved. So basically each index is the score of the chunk. So I need to get like the highest score. And then Jesus. So what I need to do is basically find the. So I need to do some shit like this. I need to find. So these are like chunk scores. Chunk scores. Let's say chunk size equals, and I think the chunk size should be 10 seconds. It's staying that video FPS and like math floor or something. Int. Alright, int. Math seal. Doesn't really matter, but you know. This is the chunks. I mean, chunk scores. It's this, and it's chunk size. Now there is this thing. So I have basically this. I have frame. And I have chunk. I have frame. These are chunks, right? Okay, so now here's the problem. Yeah, it's not just chunks like that. No, it's not a problem actually. Chunks are not like that. I have chunk. And then I have the next one. Chunk. Right? And the next one and so on. Chunk. All the way down. And now if one of these is picked, I need to invalidate all of them that contain it. And think if this one is picked, basically what it means is that the next chunk minus one. So if a chunk is picked, I need to invalidate the chunk size minus one, chunk size plus chunk size minus one, chunks left and right of it. So yeah, and I think that's true. So let's see. Chunk scores. So I have while true. And chunk scores the score of chunk last chunk size chunks are not valid because too few frames. Select chunks while true. So I'm not sure if while true is the right thing, but let's say equals 0. While true, I need to do the following thing. this many chunks of 10 seconds. So while true, I need to get the biggest one. So arc sort. Wait, to arc sort. Yeah, but I need to sort it every. Maybe, yeah, let's sort every step, even though it kind of sucks. I don't need to sort actually, I need to like max argmax. So argmax chunks course. Let's see. So this is the first chunk, the best chunk. Alright, so that means starting from that frame, so frames, let's see, picked chunks equals dot append picks, and now I need to do the following: validate current chunk and left right once, including these frames. So I need to do the following for j in range chunk size -1 x plus chunk size and do the following: chunks course j equals some bad number. If e plus equals 1, if e equals 5, break chunks. Alright, cool. So I have a bunch of chunks. Okay, cool. Said argmax, right? So that means the biggest score. Great, so the biggest difference. Nice. So yeah, they look quite different, and that's nice. Though I would have expected, yeah, maybe. Just one. Cool. Which is 300. I think this is right. So it's, what do I need to invalidate? So if I take this one, I need to invalidate chunks of 4. So 4, and to invalidate 3 of here and 3 of here. Yes, put a minus here just so it's 900. Wait, what? There's no way that changes. Oh, hold up. Okay, so now let's while true. If chunks colleagues work. Those are all the chunks, and I think, yeah, okay, cool. Cool, these are all the chunks, nice. And now, let's pick 5 of them. I need to do this for all the video, right? Do this. Yeah, just put this stuff here. Bro. Okay, let's put this stuff here. Okay. And then I have what? I have this following formula. To be honest, I think this should be cons, and I think, yeah, this is get chunks, cons and cons is and I return a list of ints, maybe chunks size. I think chunks should be part of that. I have ph chunks for the chunks, cons and def, cons still. Chunks size print chunks. I just like calling it assignment, which is my thing. Cool. Oh, and chunk size too. What? What the fuck happened here? String and string. What? constant error. Do I put values? This nan that I don't like. Ce video e asta? Video 2. Ce-s this bad boy? What? 99, 66. Amazing. There you fucking go. Cool. So that means I can do zip video names. I can print this fucker. No. Print this. except this second video, which is the YouTube one. Cool. Let's get the chunks now. So that means, let's say video the 0. This that no. Şimdi 96. All this. All this shape with this. The videos are not here. Amazing. Sir, why is this shit just not working today? Google. Jesus, show file location, bro. It's fine. We can do some other stuff. We got a technology to do it. G down. No, that's not the wrong technology. Nothing fucking works. There you go. Cool. This is what? Fuzzy. Download it? No, it didn't. What? That moved way too fast to be true. Oh. The fuck, bro. Okay, we need to do it this way. Download. 800 megabytes. Is this link? Can I use this link? 21. No thanks. Come on, you can do this. Jesus, like everything moves slow today. .28 megabytes, and I'm complaining that it moves slow. Jesus. I remember the kilobyte zero, and I still feel it when I travel and stuff, but cool. So what's the names of the videos? To be honest, I never used the videos, did I? So first one is right, second one is Bucharest, third one is Castelcorvino, fourth one is Comana, and the fifth one is Norway. Video store equals video story. Cool. Oh yeah, and it's a great one. So as you can see, it's like fucked. And if I go to the next frame, all right, that's amazing. All right, maximizing their suffering, basically. All right, so let's do the following: path, dress, collage, combined, parents, all right, and I'm gonna do this for video. I feel like it is resting here. collage combined. Take a bunch. Interesting. That's fine. 4 frames, and to the image right. I think this should work. Collage combined. I need to start like writing data, so takes a bunch. Alo? Hei, salut. Curând, foarte, foarte curând. Da, să venim direct la... Nu știu, poate veni direct la tine, dacă ajunge Vali înainte și rezolvați voi, nici nu știu. Hai, căcat, ok, bine. Bine, păi hai că spunem când plecăm de acasă, care și iar cam vreo 15 minute, spune, poate 20 maxim, da. Spunem că plecăm de acasă și ne vedem la locul ăla unde ai spus tu. Ok, bine. Dar plecăm cam în, nu știu, vreo 10-15 minute, cam așa, adică am avut niște treabă și n-am putut să trăim. Bine. Pa. Why is this taking so fucking long? Is this like not storing stuff? Oh, it is storing stuff, okay. Cool, so this is the first one. And very soon we're gonna get into the second video, I think. Yeah. I'm not sure what to say about this chunk though. Look at it. Oh, it put it as a little object, but this is like a house.
Pisica.
Da,
E târziu.
știu.
Cămița? Ah, ia
E
uite ce
pe aici
adormită.
și dânsa. Da, păi hai să ne pregătim și să mergem. Curând, da. Tu ți-ai pregătit astea? Nu știu, la mine asta mă super de gând sau ceva. Să scăpăm de dânsele, nu doar.
Putem să luăm doar două, dacă
Alege două, random, nici nu contează. Trecut și în ghestanul ăsta. Eu sunt gata cam în 10 minute, deci dacă
eu
știi...
nu sunt gata de 10 minute, de când mă dusem la așezări.
Păi nu am ieșit acum 10. Păi nu am intrat pe... Adică trebuie să fii gata.
Și ce, tu ești gata?
Păi eu sunt gata în 10 minute.
Ah, extraordinar!
Alrighty. So, let's see how this thing did finish. Most likely not, but let's see. Alright. So it's gonna be like how long will it be? So it's like 5, 25, 250. It's gonna be like 4 minutes long video. Huh. Interesting. Yeah. Very nice. This in the right order. Should be. It's gonna take a bunch. Really gonna take a bunch, but that's fine. Yeah, maybe I can like, so this is like the worst chunk for them. Is it true though? Ah, why is it the worst chunk for them? Oh. It truly fluctuates. Nice. But we are fluctuating. So yeah, maybe it's not just this. big are those files? Do I have space? I didn't think about that. Where is my chunks? Collage combined. Ah, alright. Not that bad. Maximizing their suffering over here, I swear to God. Yeah. Yeah. It's gonna be some shit like this. But I still need to wait a bunch. Yeah, maybe I should just be patient. It's gonna take a bunch of time, so what can I even do? I did a lot of stuff, so I think, yeah, this is gonna take a bunch of time. I will just have to make a video out of all of this. And I think it looks good. I think I did the right thing. Yeah, look at it, how much it fluctuates right now. Just look at that. It's great. This is a great video. Yeah, and then we go to the other scene very soon, like around here. Yeah, it's like 10 seconds of each. Yeah, I think I did a great job this time. I will close the stream here. I implemented like some nice algorithm here. So the LURP actually took more than the chunking for some fucking reason. Nice, so the chunking. The chunking was actually easy. Just over the fan. The LURP, however, man, LURPing hard here. Yeah, now I'm just waiting for this to finish. Probably going to like 20 more minutes. Anyways.